also 3 pi.
Okay.
So it's consistent. We like consistency. Okay, part B is to write a possible function. And we talked about you have to go back to where it starts and decide, okay, is it a sine or a cosine? Is it starting at that point? And it is. That's why it is a sine here. The amplitude is 5. You negate it because it's going down. Is that clear?
You don't. Oh, yeah.
Sine usually goes up. When you
Yeah.
negate it, it goes the other direction. All right. Now the rest of this, I'm going to just put this here. Bx plus b. I'll use d for the moment. So there's a relationship between the period and this b value. So we didn't talk about that yesterday, but the period is equal to 2 pi over b. You have the period. The period is 3 pi. 3 pi equals 2 pi over b. You have to solve for b.
Would you divide 2 pi by 3 pi?
Yes, b ends up being 2 pi over 3 pi, or 2/3. And that's the number that goes in here. So it's -5 sine 2/3 x. B is the midline. There you have it.
So, okay. Got it.
Nothing more to say on that. Okay. Part C. We didn't really do this last night. We didn't really write a rule. We were just sort of like, actually, let me grab a snip from the graph. Write a rule that states the location of all x-intercepts on the graph. So we know it's 3 pi over 4 and then 15 pi over 4. And we know that we're adding 3 pi each time. So the rule has to have a 3 pi in it. Okay. And the generalized rule is that it's whatever you're starting at plus the period. And you can choose either one to start at. You might as well start with the smaller one. So it's 3 pi over 4. That's what you're starting at. Plus 3 pi. And that's almost the rule. It's almost the rule. Because it worked for this first one, but it doesn't work for the next one. So you probably saw this in class. You either used K or N in class. Do you remember that?
Yeah. I remember
Doesn't.
using N.
Okay, let's use N. Every instructor class a little bit different. And N is an integer. Okay, so it's like -1 or 1 or 0 or 2. But that allows you to go up by the period each time or down by the period each time. You just have to remember to put an N after the period.
Okay. So that's just the rule for.
That's the rule, yeah.
Okay.
Any questions on that before we
No.
Okay. So for the next problem here, it says to first list the transformations of g of x. So there are 3 of them. Can you tell me any of the 3 transformations that you see?
A stretch of 3.
Vertical stretch 3. That vertical is really important.
We
know that stretch. Go ahead.
Up 2.
Up 2. And so the last one is inside parentheses here. Is it pi left or pi right? Do you recall?
Pi right.
It is pi right. Okay, very good. Now, the parent function, which we talked about last night, I messed this up real bad, but it's minus pi over 4, -1, 0, 0, and then pi over 4, 1. Those are usually the 3 points that they want.
Yeah.
Right. Now, pi right affects the x value, but we looked at length. We looked at length last night, and just to keep it simple, if it's x minus pi or x plus pi, it's still the same graph. So that actually will not affect these x values at all. If you want, I can show you that again, but it was this, the snake repeated every pi
Yeah.
like that.
Mm-hmm.
Vertical stretch of 3, that affects the y. You end up multiplying by 3. Up 2 affects the y, you're adding 2. Does that all sound familiar?
Yeah.
Okay. So before we graph it, it's good to make this new table. The x values are staying the same, but the y values, and this is where the order matters. You have to first multiply by 3 and then add 2 to
Mm-hmm.
the y values. So you're multiplying each of these y values by 3 and then add 2 to them. What does that become?
The first one would stay as -1, right?
That's correct.
And then 2,
Okay, good,
and then 5.
good. Okay, now we can graph this. All right, so the little bit more information is that the vertical asymptotes are at pi over 2, negative pi over 2, and then pi over 2. And you're asking me last night, you're like, hey, where does this point go? This negative pi over 4 is midway between the origin and pi over 2, negative pi over 2. So it's midway in between, and then, down 1 right there. 0, 2 is up 2. Pi over 4 is midway between 0 and pi over 2, up 5, 2, 3, 4, 5, like that. And then it has to have kind of a snake-like look to it. It's not straight lines, it's a little bit of a curvature, something like that.
Wait, how'd you graph the pi over 4?
It is right between 0 and pi over 2,
Okay.
right in the middle. So I guess you could even do that pi over 4 minus pi over 4 there.
Okay.
All right, so I'm pretty sure there's the instructions have a small mistake in it, but let me show you that here. So graph g of x including one full period. So that's what you have. This is one full period. So check. Labeling the x-intercept. So the x-intercept's where it crosses the x-axis. Unfortunately, it doesn't cross at a good place. I think the instructor meant y-intercept, and that we have. The y-intercept is 0, 2. The x-intercept is not possible to find without a calculator, or it has to be written in a very ugly manner, but it can be done. But I'll just suggest that that's probably an error. The vertical asymptotes are at pi over 2 and minus pi over 2. And the 2 other points, that comes from your table. So this is everything. If the question is like this or the same numbers, this is sufficient.
How'd you get those asymptotes?
So they're known from the parent function. The parent function always has asymptotes at minus pi over 2 and pi over 2. The fact that it's transformed to the right pi doesn't affect that. it has to do with the fact that tangent is sine over cosine. Tangent of x is really sine of x over cosine of x. And the vertical asymptotes occur when the bottom is equal to 0.
So the two asymptotes aren't pi over 4, it's pi over 2.
Pi over 4 is midway between the asymptote and the origin. The same thing over here. Let me clean this up a little.
Oh, the asymptotes are the dotted lines.
Yes.
Okay. And what would you do if they were asking to find the x, was it the x?
X-intercept. Yeah, so that's fine. We could certainly do that. So I'm going to grab a snip of the original function. All right, so to solve for the x-intercept, you're setting g of x equal to 0. And then you're solving for x. Okay. So to do that, you subtract 2 from both sides. Minus 2 equals 3 tangent x minus pi. Divide by 3. So you have negative 2/3 equals tangent x minus pi. You now have to undo tangent. So you undo tangent with arctangent or tan inverse. And you do that to both sides of the equation. On the right, it undoes the tangent. So you just have x minus pi on the right. The arctangent of minus 2/3 is not a known value. It's not a nice value.
Okay.
So we're almost there. You have to add pi to both sides. So I usually at this point will switch the order where the variable's on the left. So it's the arctangent tan inverse of minus 2/3 plus pi. So it
Okay.
could be that they wanted that. I doubt it, but I mean, I didn't write the test. They clearly didn't proofread it if that is wrong. But
Yeah. Okay. And I had a question on one of the other things that we were looking at
sure, yeah.
before.
Yep.
Let me just find it real quick. Okay, I can't find it, but I have another one. It had to do with like the middle behavior,
Okay.
and those things.
Okay. Do you want me to go through the same problem again or something different?
I was just wondering, because it says as x reaches 0, and I don't know if that means like right or left.
Yeah, there's got to be from the left and then from the right.
So as x reaches left 0, like,
The way this is read is as x approaches 0 from the left.
oh,
And then the bottom one is as x approaches 0 from the right. I think you saw me put that in parentheses over here, from the right,
okay, yeah.
from the left. Just a quick question. I mean, I'm just confirming you are receiving the notes by email after the lessons.
Yes.
Okay, good. So the odd one, the thing that was a little odd about this one is that from the left, it was 0, f of x or y was 0. And from the right, it was a different number. It was 1. They were different in the middle
Yeah.
behavior. which is okay. I mean, that's allowed. If you take calculus someday, you'll talk more about limits and the existence of limits, but this is everything for that. Did you also need the middle behavior as x approaches 2 from the left, 2 from the right? Those ended up being the same.
No, I think, why would it be 1?
So I'm gonna grab the snip of the piecewise function. And so you're essentially evaluating it at the 2 endpoints. So it was like from this one right here is from the left. This one on the bottom here is from the right.
Mm-hmm.
And so this one corresponds with this one here.
Oh, okay.
The other one comes from putting 2 in -2 times 2 plus 5, which equals 1. That's this one.
Okay. Okay, got it. And then I had another question. I'm trying to, okay, I found it. The one that was like solve the location of where the vertical asymptote of the function lies. Would the answer just be -8? Like, that's
Well, it's an equation. So you're writing an equation of the line. I'm trying to find my cursor. There it is. The oh, I don't want that. Sorry. Yeah, so it's like this. X equals -8. That is the equation of the vertical asymptote. Does that answer your question or not?
because I noticed that in the equation, you put in like a 2 on both sides.
Yes, I was
And
setting
you
the in
said it.
you're setting this equal to 0. And so you have
Okay.
to solve for X. You can undo the 1/2, or you can just set X plus 8 equal to 0. Either way is okay.
Okay. So, okay. But what would happen? Oh wait, never mind. That would just turn to 0. Okay.
Correct.
And then okay, that makes sense. Um, yeah.
If these are very similar to what you expect to see,
Mhm.
always good to redo the problems on your own and just make sure you're comfortable with the steps.
Yeah.
Any sort of oddities, things like that.
Yeah.